And next is Darren Schulte from Apixio.
Hello, everybody. Thanks for your time today. So I'm going to take a different tact and talking about use cases of big data and talk specifically about healthcare. And hopefully that's of interest to you all because you will be a patient or you have interacted at some point since birth with the healthcare system. And this is where, in a particular domain, using big data is going to, we believe, solve some of the most intractable problems that we're seeing. And certainly that's one industry in our economy and across the world in which we really need a lot of help. Apixio is a company in the Silicon Valley, about 3 years old. My name is Darren Schulte. I'm the President and Chief Medical Officer of Apixio. I am a physician by training, but for the last decade or so I've been around in clinical analytics and technology-oriented companies. I haven't practiced in a while, but certainly stay as close as I can be. Apixio is a big data platform with specific enabled solutions. So we don't sell a platform, but solutions that solve real problems for healthcare systems, provider groups, and payers across the U.S. And increasingly in other areas around the world. We have an alliance, and we're happy to talk about that at some point with Intel, certainly optimizing our stack and getting onto Intel's distribution of Hadoop. And we've been recognized by GigaOM as being #1 big data platform in healthcare. Let me describe for you briefly some of the major trends in healthcare today in the US, and certainly to some extent around the world, which is really the impetus for being able to leverage big data. As you may know, over the last several years, as part of the Stimulus Act, the federal government has subsidized to the tune of nearly $40 billion the adoption of electronic health records by physicians. No longer is that data sitting in a stack of papers or folders with scribble-scrabble in someone's bookcase, that being your healthcare record. You take that and you marry the fact that healthcare is being changed in the way it's being paid for. We're fed up with paying for fee for service. Everything you do for me, I just pay you. Now we're shifting towards a model in which government payers and private payers are now paying according to value. What are the outcomes and the quality you're providing, not just the services you're rendering. And then third, we're having greater access in the healthcare system with the advent of Obamacare, and the costs continue to rise. Put that all together and you need data. The data is being liberated, but you also need it to tell you how you're going to run and provide value and outcomes in a healthcare system that to date was only worried about how many heads are in the hospital and how many people are filling my waiting room in terms of the economics. So let me tell you a quick story about why data is increasingly important and it has real consequences. This was a published study in the New England Medical Journal 2 years ago that happened at Harvard. Here was a case of a woman who came into the emergency room, and she almost died from a blood infection. Blood infection caused by a bacterial pneumococcus that is imminently treatable. This woman had had her spleen removed 8 years prior. And for those people with spleens that are removed, they're more susceptible to bacterial infection, and they need a pneumococcal vaccination on a regular basis. Standard of care, no one would object. And she almost died. And she was being treated, by the way, in Harvard's healthcare system on an electronic record, one of the first adopters. And they went back and said, what's going on here? Why is, in fact, this woman did not get a very simple vaccine that's evidence-based? No one would dispute it. And the folks went back and the researchers said, well, 71% of data about persons who had splenectomy was not coded or billed in billing data. It was not machine readable, it was in text, not surprisingly. And that text was only understood by the physician, but not the organization. 71% did not have their splenectomy, a history noted in their medical record. Not surprisingly, they went back and only 17% of those without a history of splenectomy in a code, in a billing code you can use to operate on, they were only 17% likely to get a pneumococcal vaccination versus only 54% that actually had it coded, so that's certainly another problem in the healthcare system. And so what we're doing is we're leveraging, we have lots of data that's now in textual form. Big data in healthcare is a noun and a verb. The noun is that we have lots and lots of information. And I'm not even talking about genomic data. I'm talking about most of that information that your physician is typing away in the EHR every day, if they have one, or writing down or transcribing. And then you bring into bear lab results and other billing coding information and mobile device data, if in fact you have direct-to-consumer healthcare apps. So lots of volume, much of it is unstructured, and we'll talk about that. There's a large variety of it. It goes to structured, but most of which unstructured. And I'm not even talking about images for radiology, just all the ways in which you're taking down the data. The value that you're going to bring from it, and we've talked about that in terms of big data in other areas, is to analyze those data and find the patterns and find ways in which you can automate this recognition for use in different cases in healthcare, so you're not dependent upon the physician's memory, the nurse querying, or some other person to think about what do I ought to think about for this patient. Increasingly, it's not just the patient, but how is my population doing? So that we're proactive in our care, and we're not just thinking about you when you're in front of me in the office. That's the value, and the velocity of data is scalability around the data storage, but also deriving insights from that data. Data that can be derived as insights on a batch-oriented basis or in real time with respect to decision support you may have, for example, in that ICU or that ER or the like. Let me take a typical volume for a healthcare system. This is a 2-hospital health system in the East Bay in California, 200,000 patients. If you look at just 5 years of data in an electronic record, it's 10 terabytes of data. 10 times more information about patients is in that narrative in that 10 terabytes of data, and that represents the entirety of the Library of Congress. And that's 200,000 patients. And you multiply that across the whole of the healthcare system, and you've got large volumes of data. Much of that data, 80% of which, is textual information, 80%. Kaiser reports recently 90% of the data about their patients is textual. When I mean textual, it's not coded. Coded data is generated for purposes of billing. And with that coded information, it's in a code that's machine readable, at least in the ways and the technologies have been leveraged with healthcare. So we got a richness in textual data, increasingly digitized in various forms we can operate on, and that's certainly where big data can come into play. By the way, every day in the US, 1.5 billion, at least this was estimated, 1.5 billion documents are created each and every day. All that richness of information about each and every one of your healthcare and everything that you do and interact with the healthcare system. Certainly if your physician's on electronic records, and even if they're not, they're transcribing it into some notes to make digital for various purposes. This data variety can break any sort of data model, relational data model that typically is used in much of the technologies employed in healthcare today. Healthcare, by lots of standards, is about 20 to 30 years behind in the technologies leveraged in the other industry verticals that we'll discuss here today. Not only is there data handling challenges in the way in which the data relates to one another, there's duplicate information, there's multiple systems of coding, proprietary and standard in terms of representing that data. And then how do I extract meaning from text? The physician's going to say, well, this patient has a prior history of an MI. That's text. I have to extract meaning from that. I got to do something with that. It's rich, and it shouldn't just sit there for one physician to think about, remember, and do something with. Again, I want a proactive healthcare system in which I can determine performance and quality, determine who's performing and who isn't, and figure out how to change the delivery for the better. That'll break any sort of a relational data model in ways in which typically it's being done today. So then the first step that we, as Apixio, had to encounter, and this is something that is across healthcare, is how do you interoperate between ways in which to represent a concept. And a concept could be a heart attack. A heart attack is a way in which it's colloquial. Heart attack could be an MI, myocardial infarction, a code for MI. It could be other ways to represent MI in various different means, acute myocardial infarction, et cetera, et cetera, et cetera. It's called interoperability. Typically in healthcare, what you do is you do a manual mapping. I'm going to map from one system to the next and figure out how these codes and concepts relate to one another. But when you start including textual data, all bets are off. So we used a big data approach in a knowledge graph, in a way in which, for example, Google creates knowledge graphs to determine and interoperate between concepts on the web for purpose, say, Google Translate. So we took the leaf nodes of existing ontologies, and these are ontologies to codify data for billing purposes, such as ICD-9, which is a disease codes, Snowman and others, and extracted a dictionary. From there, we took literature on the web, National Library of Medicine and other sources, and we married that with terminologies and concepts that relate in clinical documentation. By the way, Apixio has 1.4 million patients, which is as much as 10 years worth of data. Multiple terabytes of information. From there, we can relate in a 2x2 matrix, statistically correlate or determine the co-occurrence between these concepts and how they relate with one another to create a knowledge graph where 1 here is a synonym, diabetes type 1, and DM type 1 here not shown is a synonym, or diabetes type 2 here and DM2. And then much less closer to 0 would be an echocardiogram is much less related to diabetes type 1 in the way it co-occurs in their usage within medical literature and medical documentation. So from here we can interoperate between all manner of different sources of information that may represent a particular concept about a patient. So our platform, quickly, because this is an area in which you need to scale. By the way, if you think about the data for a moment, you say that if you look at this textual information in scanned documents, 80% of the record. With scanned documents, those are documents in which your physicians is sharing information between one another. And they rev up the fax machine and they fax information one to the next. And it becomes a scanned record. Well, you can liberate that text with optical character reader technology, but it's very computationally intensive. It takes something like that 200,000 patient health system I described, takes on the order of 60,000 machine hours to do OCR across that 5 years worth of data on their scanned documents. 40,000 machine hours to tag related concepts within textual data, and about only 4,400 machine hours to do coded data analysis. So you're going to need a parallel computing platform is where we have specific platform that's scalable using Hadoop-based infrastructure. So we take in the data, normalize it, put it in a NoSQL Cassandra data object, and then run analytic agents over this data object, crawling through it for specific inferences we're looking to make for various purposes with different algorithms, machine learning based and otherwise, to create event streams of data for purposes of determining quality. And I'll describe certain use cases and other types of use cases that are then able through an API to be used by particular applications for point of care and for other batch-oriented reporting processes. So let me take one use case of this very quickly. So this is quality measures. So quality measures is transparency. How is my physician doing? For example, we know more about the car we're driving, the food we're buying from the grocery store, or the meal we're about to get at a restaurant. We know more about that than really the quality of care my physician is providing. And how do you ask about what the physicians are doing and what care they're providing? You ask your friends, you go on Yelp or what have you. There's a determination made that's not good enough. So there's now quality performance measurement that's being done by physicians on their own, but also by those that are paying for health care. And these quality measures are based on evidence-based guidelines of care. But much of the data used for these quality measures is based on data that's in the text that can't be relied in that coded data. So it's not being effectively addressed. And if it's in that textual data, what happens is you often have to go to the file and try to figure out what's going on. That doesn't scale across hundreds and thousands of physicians for whom you want a quality report card. So we've developed machine learning algorithms that are trained to look at and infer facts about the patient that are in the textual data that would be used to determine particular aspects of a patient care for quality measurement. In this case, it would be evidence of heart failure as a starting point. How many heart failure patients treated for this physician have gotten a particular medication there ought to be gotten, or a lab test? But this heart failure can't be understood from billing data, it has to be understood from the textual information. So we've employed machine learning, some natural language processing, and other statistical methods to infer facts about patients within that textual data. And then with this text mining, we've enabled a pretty good precision and accuracy with respect to facts about the patient used for these quality measures, getting away from what the previous speaker was talking about, that manual querying of the data. And this then you can create report cards of physicians and others that will lead you to understand the quality of care that you're receiving, which is the starting point for a value-based healthcare system. And so here we're talking about basic things that ought to be done for diabetic patients, or that pneumococcal vaccination I talked about earlier in the talk. And here is where the data is going to be mined from the text because it's not really reliably understood from billing data. And this is some of the results we've achieved. And this is just talking about where with textual data we've determined a greater adherence to a measure related to diabetic kidney disease screening, 45%. This is the same patient population, same data, but when you mine the textual information, you actually find the quality is there. When you're able to use the information and the textual information, not in that coded billing data that is relied upon today. And why? Because data science really hasn't caught up to healthcare. Because there hasn't been the incentives or reasons to really use it from a business perspective. The care network is one other thing, and I'm almost out of time here, but this is another example of where you want to understand how physicians are referring among one another and referring to specialists. You want to know that my primary care physician is referring to the best specialty care, and knowing that that interaction between physicians and a social network is one that's high value. So what we did is we mined all the textual information we can understand to determine how patients are being cared for among a network of physicians. You want a high-quality network of physicians and care providers, not just one or two. That creates a value-based network of physicians and others that you would like. So we did that work, in which case to understand all the different ways in which providers, consulting physicians in and out of a care network are treating patients among these. Think of it as a social network for physicians in pattern recognition. And with this, we're able to model, for example, all the referral patterns to particular network radiologists. Why is this important? This one happens to be a very expensive radiologist that overuses tests a lot. So when you're wondering, how do I try to get down to a lower cost, high-quality healthcare system, you need to understand how physicians and others are treating patients among each other and referring among each other, and what are they doing inappropriately or not. This is not a gotcha moment. This is a learning healthcare system, but you can only understand that from understanding the patterns and the data and what the data tells us. I'll leave you with this. There's much to be said about genomic medicine. But I'll start from biology, and I'll say this. There's a lot to be understood from the phenotypic understanding of an individual, right? The phenotypic understanding of an individual can start from that textual data. You can recognize concepts and tag them in various different ways and flavors, some of which I've talked today, to create a mathematical representation of a patient in a high-dimensional matrix over time in a temporal sequence, to create that phenotypic fingerprint of a patient. So now we can create patients like me, and over millions of patients, conduct virtual clinical trials, risk adjustment models, predictive risk models. We can actually get to evidence-based medicine. Right today, only 30% of anything a physician does to you is at all evidence-based. And whatever that is based on clinical trials that probably are not patients like you. So, take the data, create a phenotypic marker, patients like me, run trials, what works, what doesn't. Now we get to a learning healthcare system. And that's what the big data in healthcare ultimately would get us as a way of improving the cost and quality and really outcomes and making us really achieve what we would like. So that's a summary of big data, almost out of time. But if I leave you with nothing else is to say, healthcare is a rich space in which to really leverage textual information and unstructured data and apply data science to really helping each and every one of us have a better experience with the healthcare system and make it truly evidence-based and one that is a high-valued system and experience. Thanks.
So, Darren, thank you very much. I have one question to start off with, which, as you know, everything you've been talking about for the usage of this has to do with ultimately improving the quality of care and the consistency of care and so forth. But I kind of imagine at a certain point in the evolution of this that the large healthcare companies and insurers would be very happy with this, not only for that reason, because it would help to identify the very small percentage of providers who are sort of operating beyond the pale. Do you comment on that?
Right. Yeah, I think it's a good point. I mean, I think those that pay for healthcare, and it's insurers, but it's also anyone who works for HP, IBM, Intel, they're all paying for your healthcare. And so they're interested in who are my physicians and care providers that do well and who are ones that don't. And it's a good point. Today, we're starting to understand how to get transparency in healthcare. Again, not for a gotcha moment, but like anything else, you want a high-quality experience. And today, finding a physician still remains ask my friend, go on Yelp, and insurers don't have much more in their toolkit, or payers for healthcare. large employers. And that's why costs of care are going up. In any other marketplace, we have transparency. Transparency gets us the best quality at the lowest price. But we don't have that in healthcare for many reasons. But with insights like this, I think we're going to start to get that transparency we all desire to get that better experience.
One other quick one. What are the computing tools that this is working on? Is this a server, a laptop?
Yeah, we're on the cloud. We're on AWS now. So we have the parallel computing kind of elastic platform that's Hadoop based with our NoSQL data store. Amazon does well for us now in terms of elasticity. It may not, and it addresses some of healthcare. Some of the healthcare issues you have to be mindful of is with the security and privacy, you need to encrypt everything that you do, both in rest and in transit. And so therefore, it places a lot of computational intensive procedures when you're encrypting and unencrypting to do analysis. So Amazon's okay as a way for a data store and to enable that, but probably other data centers we would be looking at, and partnership with Intel certainly is one where we can leverage that for many more millions of patients that we're going to be on board.
Just to know, one of the things you've heard so far from MCN and also from Apixio, and it's one of the reasons that they're right here, other than just the impressiveness of what they're doing, is that in the commercial sector in particular and this is all technical computing, this is not transaction processing simply, are really doing a lot of pioneering work out of the commercial sector on algorithm development for exploiting public clouds. So that's really interesting. Other questions for Darren Schulte and Apixio? Thank you.
Thank you.